So, good morning guys. So, our topic for today is all about the stresses in beam. So, as you can see in the figure, so, determine muna natin yung mga parts na isang concrete building. So, as you can see, so we have, so sa pinaka-bottom na part, which is the substructure, we have the isolated footing. Then next, so we have the columns. So, ayan, yung mga vertical. Then next, so ito, so we have the shear wall. Then next, so ito is yung ating columns, then beams. Then ito is yung ating slab. So those are the typical uh, concrete building parts. So next, so for the stresses in beams, forces and couples acting on the beam cause bending or flexural stresses and shearing stresses on any cross-section of the beam, and deflection perpendicular to the longitudinal axis of the beam. So if couples are applied to the ends of the beam and no forces act on it, the bending is said to be pure bending. So if forces produce the bending, so the bending is called ordinary bending. So for the assumptions, so in using the following formulas for flexural and shearing stresses, it is assumed that a plane section of the beam normal to its longitudinal axis prior to the loading remains plane after the forces and couples have been applied, and that the beam is initially straight and of uniform cross-section, and that the modulus of elasticity in tension and compression are equal. So, ibig sabihin, yung modulus of elasticity daw natin, is equivalent in tension and compression. So, for the bending stress, formula natin is equivalent to My divided by I, where Fb is the bending stress, then M is the moment, then Y is the centroid of the material, and I is the moment of inertia. So, Fb maximum is equivalent to MC over I, where C, yung C natin is kalahating distance nung material. So, kapag rectangular lang siya. So, ayan. So, for the flexure formula, so stress caused by the bending moment are known as flexural or bending stresses. So, as you can see in the figure, so kapag meron tayong beam from point A up to point B, then meron tayong in-apply na load, which is W. So, kapag nagkaroon ng load yan, which is downward, so magde-deflect din yan downward. So, yung nasa taas, so nagtitend siya as compression. And yung nasa baba naman, so ang nangyari sa kanya is tension. So, ayan. So, that's all for stress in beam. So, punta na tayo in example problems on how to determine the stresses in beams or bending stresses.